Welcome to this video where I'm going to go over some common mistakes that are made by mathematics students, and hopefully you'll avoid these. One thing for sure though is you have to recognize that what you're doing is a mistake, otherwise you'll continue to make it. So I'm going to look at some statements here, and I'd like for you to look at the statement or the equation, whatever I have here, and see if you can decide whether it's a true statement or a false statement. Because some of these will be true, some will be false. So here we have x plus 2 over 2 is equal to x plus 1. So look at that for a few seconds. And decide whether it's true or false. Okay, that should be enough time. This one is false. And it appears what some students do is they'll do this. They'll say, okay, there's a 2 here, there's a 2 right here. Those divide out. So I get x plus 1. But that is not a legal operation. I can show you with just numbers. Okay, so let's just look at 6 plus 2. Instead of an x there, I'm going to put an actual number. Like that. Say, okay, let's put that over 2. Okay, well, let's see. Okay, since we have numbers, we can just go ahead and add them. 6 and 2 is 8 divided by 2. This is going to be 4. Let's see if we do what's done in number 1 and do this. Comes out to 6 and 1 is 7. Some students will just cancel this all together and say, okay, these cancels, I get 0, and now they put x, which is also incorrect. Now you can only do cancellations over multiplication, not over addition. So if you wanted to, you could do, for example, here in this case, I could say, let's factor out a 2. Okay. Like that. Okay, so this becomes 3 and plus 1 times 2. That's the same thing. Okay, so now if I have the 2 here, now on top of the numerator, I have a product here. So I can cancel these out. Okay, those divide out. These are 3 plus 1, which is equal to 4. Okay, so you can do cancellation if you have an implied product. Don't do it through addition, because it's the mistakes that are made. Okay, so let's cancel this out. We go to the next one, and again, I'll give you a few seconds just to look at it and decide whether this is a true statement. 2 to the negative 1 is equal to 1/2. So in other words, we have a to the negative 1, where a is not 0. Is that the same thing as 1 over a? And that is true. That's one of your definitions, where the base here cannot be 0. Because otherwise you have 1 over 0, which is undefined. So number 2 is a true statement. Okay, let's go to the next one. Okay, so if you look at number 2, it looks like if you have 2 to the negative 1, okay, that's 1 over 2, which is true. 3 to the negative 1 is 1 over 3. 4 to the negative 1 is 1 over 4. So you get the idea, okay, well, if it's got a negative, we can just take it to the denominator and put a 1 on top, and that takes care of it. Okay, so if you look at number 3, do you think that's true or false? That one is false. Okay, So the way it works, you see, the problem here is, okay, you have this should really be like this, 1 over x on the top, 1 over y here, okay, and then you have z here. Okay, and then we simplify this further, okay, we're allowed to multiply the numerator and denominator of fraction by the same non-zero value. So if I multiply through here by, say, the LCD of the denominators on top, it would be xy. This actually comes out to, okay, so xy times 1 over x. This times this, the x's would cancel out. This would give me a y then here. For the next one, this times this, the y's cancel out. That would give me an x. And in the bottom, I would have z, x, y. Okay, so that's what it should be. So this is not legal, this is false. Okay. Go to the next one. 2 plus 5 times 3 plus 6 divided by 3 is equal to 9. Is this a true statement? And the answer is, it's false. Okay, so what the student is 7 times 3 is 21, plus 6 is 27, divided by 3 is equal to 9. Okay, but if there's no parentheses in something like this, the order of operations is multiplication and division are done first, and then you can do any additions or subtractions. So in this particular case, you have to do the multiplication right here first. So this should be 2 plus 15. Then you can do the division over here. This is 2. So 15 plus 2 plus 2 is 19. Now this would work the same way if you have algebraic expressions like 1 over x plus 1 or x squared plus 1. Okay, the order is still the same. Now if you had parentheses here, if you put parentheses here like this, then you can go ahead and add those two and then multiply by 3, and then you would add the 2. Okay, but if there's no parentheses there, you do the order of operations is multiplication, division, and then you do any additions or subtractions, and then you go ahead and compute it out. Okay, so be careful with the order of operations. Look at the next one. X times y in parentheses squared is equal to x squared times y squared. Okay, that's just your basic rules of exponents. Pretty straightforward. So that one is true. That one is true. Number 6. X plus y quantity squared is equal to x squared plus y squared. Okay, that one is false. Okay, I hope I gave you enough time to think there. But that's a mistake that a lot of students make. I've seen even advanced students in mathematics make mistakes like that. Sometimes not because they don't know, because they're just doing something quick and they're not thinking. that happens. Okay, so again, let's use numbers here. So you can see 3 plus 2 is squared. Okay, we're going to say we want to square this. Okay, well, let's just, since they're numbers, we can just go ahead and add them. 3 and 2 is 5, and then you square it, so this is 25. Okay, now we follow this rule. It's a sum, so I square the 3, I get the 9. Get 9. I square the 2, I get 4. Okay, so if I do it this way, then I get 13, which is not the same thing as 25. Okay, so this one is false. Okay, and number 7, x plus y quantity squared again, and of course this is the correct answer. It's supposed to be this, right? X squared plus 2xy plus y squared. Okay, if you do the multiplication, okay, x plus y quantity squared you have x times x is x squared, y times y is y squared, and then you multiply xy and multiply this way, you get xy. 2xy comes out to 2xy. Okay, so that's just your regular formula for squaring a binomial. Clear this. Okay, minus 2 cubed is negative 8. Is that a true statement? The answer is yes. It's a true statement. Okay, before I go to the details of that one, let me go to the next one. Negative 2 to the third in parentheses there. In this case, I have the negative 2 in parentheses to the third. Is that negative 8? And the answer is yes. Okay, so those are true statements. Then we'll go over these in a minute. Negative 2 in parentheses squared. Is that negative 4? This one is false. It's a positive 4. The next one. Negative 2 to the second. Notice no parentheses. Is that a negative 4? And that one is true. Okay. So let's look at this. If you have it in this form, like number 8, this actually means this. Okay, so this means, okay, 2 to the third. So this base right here, this exponent rather, applies only to the base 2. So it's actually, it'll be written this way. So 3 factors of 2. Okay, so do it again. Okay, so it's negative, and then 3 factors of 2. So it'd be 2 times 2 times 2. So 2 times 2 is 4 times 2 is 8, and then negative, so that makes it a negative 8. Okay, so that one, like I said, it was a true statement. Now over here, I have negative 2 to the third. That's 3 factors. In this case, the base is negative 2, because it's in parentheses. So again, multiply this out. Notice the format is different, but the answer is the same because, again, it's an odd number. So an odd number of negatives is still going to be negative. Negative 2 times negative 2 is 4 times negative 2 is still negative 8. Okay? But now over here, the exponent is even. So negative 2 to the second, this one's in parentheses. So that means 2 factors of a base, which is negative 2. So it's negative 2 times negative 2. Here, negatives cancel. This comes out to a positive. Okay. So it does make a difference. It does make a difference if you have parentheses on the whole base, especially if it's a negative. Now, if it doesn't have a sign, there's no difference whether it's even or odd, but it does make a difference if you have a negative in front of it. Okay. So cancel this out. The next one, negative 2 to the second is equal to negative 4. Well, that one kind of looks like number 8. Okay, negative 2 to the third is equal to negative 8, except in this case, it's the exponent is 2. Okay, so this one is true. Notice this one over here was false because, again, the base was negative 2, but here the base is just a positive 2, so it means, oops, it means a negative and then 2 factors of 2. So 2 times 2 is 4, and the negative makes it a negative 4. Okay. So this one is true. Number 10 is false. Okay, so it makes a difference on whether you have parentheses and whether the power is even or odd, especially if you have a negative base. So be careful with those so you don't make those mistakes in your classes. In the next video, I'm going to do a part 2, a little bit more advanced video on other mistakes that are made in courses. I'll focus on algebra, but I'm not into some other more advanced examples. So have any suggestions, please post them. And I'm going to continue with other videos. So I hope you subscribe and keep watching, and we'll see you next time.